Okay, since the projector has problem, so I will just use whiteboard. Okay. Okay, so I need you to look at the either you join to the Teams or you look at the notes the page of find of 16. Okay, the slide of 16. Okay, Lagrange interpolation is actually similar to Newton's interpolation, where it is applicable to both equally and unequally spaced data. Okay, equally and unequally spaced data. So the formula is totally different. Okay, the formula is totally different. I will go straight to the general. Okay, the general one. Okay, the formula for Lagrange have f and x. Okay, summation. Okay, I equals to 0 up to n, and you have Lix and fxi. Okay, this is the formula. Okay, this is the formula for the Lagrange interpolation. Really see it clearly. I need to adjust a little bit this. I think good. Okay, this is the formula for Lagrange. Okay, this one where your Lix has the formula of this big time. Okay, big time. J equals to 0, but J is not equals to I up to n. So inside here, you have x minus xj over xi minus xj. If we use this formula, okay, so this big time, okay, big time, it means if you have this one, I equals to 0 up to 2, let's say 2, and you have xi. So this means I start from 0. Okay, the first one will be x0. Okay, x0. Next will be x1. And because of this big pi, it means it will multiply to the x1. Okay, then multiply to the next one, I is 2. Okay, when I is 2, then we stop. This is what big pi. This is the difference between the summation. Okay, summation xi. This means the first is x0. I start from 0. Next will be plus. Okay, for summation, we have plus x1 plus x2. Okay. So you see, this is a big pi. Okay, big pi. That means we have this one when j equals to 0. When j equals to 0, we have this, and then multiply to the same thing when j equals to 1, up to j equals to n. So you have this one multiply to the same thing for n minus time. Okay, for how many times? 0 up to n for n times. Okay, for n times, because j is not equals to I. Okay, this is for Li. So I give you one example so that you can see it clearly. Okay, what it means by j is not equals to I. Okay, I start with for a quadratic. Okay, for a quadratic problem, we have x0, y0, x1, y1, x2, y2. Okay, to form a quadratic polynomial function, we need 3 points. Okay, we need 3 points. And this I, that means I is 0, 1 up to 2. Okay, 0, 1, 2, the index value. And here our I start from 0 up to n. That means your n is 2. Okay, n is 2. So your f, okay, your fx, when we expand this one, it will start from 0. Okay, so you have L0x, fx0, the first one. And then plus, because of the summation, we have a plus L1x, fx1. Okay, L1x, fx1. Okay, and then plus when I is 2. When I is 2, we have L2x, fx2. Okay, so this is the formula, the general one. This is totally different from the Newton interpolation formula, right? The Newton's one, we have B naught plus B1 x minus x naught plus B2 x minus x naught x minus x1. But for Lagrange, we have this. And you have to know what is this. Okay, L naught, L1, L2. Because your fx naught is actually your y naught. Okay, fx naught is the first one. Okay, this one is actually your y naught. This is your y1. This is your y2. Okay, you can get the values from the given points. But for the L, okay, for the L, when we look at how to get the L naught. Okay, L naught, we use this formula. Okay, we use this formula. L naught means your I is 0. Okay. Now we want to get the function of this. L naught means I is 0 now. When I is 0, okay, we have this. Okay, we have this. So we will start from x minus x0. Okay, I is 0. This one is j. Okay, this is j. So your j start from 0 up to your n is 2 now. Okay, your n is 2. So it means not only I, your j is also starting from 0, 1 to 2. Starting from 0 up to 2. Okay, your both I and j index values are 0, 1, 2. Because this is your I. J starting from 0 up to 2. We have 0, 1, 2 for your j. Okay, your I is 0 now. I is 0. So what is your j? What is your j? Your j will be 1 and 2. Because j is not equals to I, we are looking for L naught x. Your I is 0 now. So your j will be 1 and 2. When we are looking for L1, your j will be 0 and 2. 0 and 2, because it starts from 0 up to 2, but j cannot be the same with I. So when we find for L2, your j will be 0 and 1. Okay, so back to this one, 0. So your j is 1 and 2. Okay, 1 and 2. So the first one is 1. Okay, so j is 1 now. When j is 1, we have this at the top, ax minus x1. And this is I follow this. What is your I now? 0. 0. So you have an x naught here minus. Okay, this one follow this. 1. So x1. Okay, so this is j equals to I. And we have. Oh, okay. I think these are the students from another lecturer because I swapped the classroom with another lecturer. Okay. So j equals to 1, and we have another j value, which is 2. When j is 2, okay, because of big time, we will multiply this one to another one. Okay, multiply. Now when j is 2, you have x minus x2. You have x minus x2. This one will be
1.
x. What is your I now? What is your I now? 0. I'm looking for this one. This function is your L0. Okay. X0 minus x, follow this 2. So this is your L0. Okay, this is your L0. Followed by this one, fx0. Okay, now you have done L0. Next, L1. Okay, L1, I is 1. So your j will be 0 and 2. 0 and 2. Okay, this one. Okay, 0 first. So x minus x0, x minus x2. 0 and 2, your j. And down here, xi. Your I is 1 now. Okay. Okay, your I is 1 now. Okay, I is 1. So this is your x1 minus x0, x1 minus x2. So this is fx1. Okay, and the last one, I is 2. So your j is 0, 1. So here, this will be x minus x0, x minus x1. Okay, and then down here, this will be follow I. I is 2, x2 minus x0, x2 minus 1. So x2.
And sampai dengan dulu tu jumlah tu yang paling tinggi.
No, this is for second order. I use second order as the example. This is for quadratic polynomial. Okay, so you see, this formula is totally different from the Newton's. The Newton's interpolation. This is much complex. Okay, any question for this one? Any question?
No.
Okay, if no, I want to show you the one with 4 points. Okay, the one with 4 points. Okay, this one actually you don't have to copy because this is given in the slide. Okay, this is given in the slide. I just want you to understand how to form this. Okay. It's problem. Okay, now let's say we have 4 points. Okay, 4 points. X dot y dot, x1 y1, x2 y2, and x3 y3. Okay. So our F3 will be, okay, you have to come up with this, your L and F. L and F. Okay. So I always start from 0. So L naught, X, F, X naught, L1, X, X1, L2, X, and X2, and
L3,
L, X, and X3. Because your I starts from 0 up to 3. I is 0, 1, 2, 3. 0 up to 3 now. Okay, so we have this 4 terms. So L naught now.
X.
What is the L naught now?
X.
Minus
S1.
Okay, 0. That means our J will be 1, 2, 3. Okay, 1, 2, 3. So X minus X1, X minus X2,
X minus X3.
Okay, after you settle the top, okay, the one from the bottom,
That's not.
X naught, X naught, X naught.
X1. X1 is 2. X naught. X minus X3 is 3. X naught.
Okay, so same goes to L1, L2, L3. Okay, L1, 1. I is 1. That means your J will be 0, 2, 3. Okay, 0, 2, 3. So it will always start with X, the variable X. X minus X 0, X 2, 3. This will be
S1. S1.
yeah. So this is X1 plus, okay, I is 2. 2. That means 0, 1, 3. 0, 1, 3. So X minus X0,
X minus X1, X minus X3.
3. Yes. Okay, I is 2.
X2 minus X5, X2 minus X3, X2.
X 2. And last one. L I is 3. I is 3. That means 0, 1, 2. Okay, 0, 1, 2. 0, 1, 2. And your I is 3. Okay, so this is the formula for cubic polynomial. Okay, cubic polynomial. So now it's back to the most basic one. Okay, the most basic one. When we have only 2 points. We have only 2 points. 0 and 1. So your formula will be up to this. So what is the L naught?
Not S minus S1.
X minus
No, it's 0.
X minus
S1
Okay, so this is the most basic one. Last year and last 2 years, Lagrange interpolation was come up in finite variable. Formula is not given. Okay, formula is not given. You have to know how to form the L, and you have to know when to use the first order, second order, or third order. Okay, you have to know how to decide which order to use. Okay. Okay. Sometimes the question it will mention clearly. Okay, I want first order or second order. Sometimes you are given a set of points. Okay, use all the points to construct a polynomial. Okay, a Lagrange polynomial. Okay, then you have to know what are the order. Okay, what is the order? Okay, so now we have done with the formula. Here I want to show you the example. Try to get better. Fine. So this is the formula that we saw just now on the whiteboard. Okay, same exactly. Okay, it's just that the one on the whiteboard, I put everything on one equation. Okay, here I separate the L because I want to show in a bigger form. Okay, this is for L0. This is for L1. And the fx0 is taken from the point. Okay. Okay, now we look at the first example. Use Lagrange interpolating polynomial of degree 1. Degree 1, that's mean 2 points. Okay, 2 points. So that's why you see these 2 points. Okay, these two. This is x, this is y. Okay, when x is 4.3, your y is 0.1678. Okay, this is another set. This is another point, x and y. Okay, so this one, first order. So that's why we have this. Okay, first order, this means 0 and 1. We have 2 points, 0 and 1. So when I is 0, our j is only 1. Okay, 1. So this one follows this. Okay, this one follows this. When I is 1, your j is 0. Okay, then you substitute all this x0, x1. Okay, you take from the point. This is your x0. This is your x1. You substitute the x0 and x1 into all this. Then you will get this one. Okay, so if you put everything in one line, this is what you are going to get. Okay, actually for linear interpolation, you can put everything in one line. Okay. So after you substitute the x0, x1, and also the y0 and y1, this is what you get. Okay, this is the Lagrange, first order Lagrange interpolating polynomial. Okay, next. Okay, back to the question. You are asked to estimate this one. When x is 4.7, what is your f? Okay, when x is 4.7. Finally, you just substitute all the x by 4.7. Then you can come up with this 0.2193. Okay, the process actually is similar with the Newton's interpolation. It's just that the way we get the values here is different. Okay, Newton's we use table, Lagrange we use this formula. Okay, this is for 3 data points. Okay, this is what you saw just now. Okay, 3 data points. That's mean 0, 1, 2. Okay, 0, 1, 2. That's why you have L0, L1, L2. And for 0, that's mean we use 1 and 2. 1 we use 0, 2. Okay, 2 we use 0, 1. Okay, remember this one, we follow this. Okay, and this one, we follow the one from the top. Okay, we look at the example. Okay, polynomial of degree 2. We want to use polynomial of degree 2 to estimate this one. So you are given these 3 points now. Okay, these 3 points. So after you form the L0, L1, L2, and after you substitute all the values of x0, x1, x2, you will get this. Okay, this one you can simplify. Okay, you can simplify, but this one you don't have to expand. You don't have to expand. Because we just want to use this to estimate for f negative 3.8. Okay, we don't have to expand. You just simplify the one from the bottom, the denominator. Okay. If you put everything in one line, this is what you will get. Okay, everything in one line. So L0, L1, L2. And after you substitute the x0, x1, and x2, okay, you get this. All this. This one you simplify first. And then these are the y values, y0, y1, y2. And finally, we substitute the x with negative 3.8 to find the estimation. Then we get this.
Yeah. You get bracket 1.0823.
1.0823. These are taken from the points. You are given this point. This is x, this is y. X, y, x, y. So x0, y0, x1, y1, x2, y2. Or we can, this one we can address this as fx0, fx1, fx2. Okay. Okay, now we try this. Okay, we find this. I think we go to this one first because I'm not sure whether the projector cooperates or not. Okay, we look at this 4 data points first. Okay, this one you have already gone through this. Okay, 4 points 0, 1, 2, 3. Okay, 0, 1, 2, 3. And when I is 0, we use 1, 2, 3. Okay, when I is 1, your j will be 0, 2, 3. That means anything other than I. Okay, so these are the formula. Then we look at the example first. Okay, construct a Lagrange interpolating polynomial of degree 3 with the set of points here. You are given 4 points. We want to construct the Lagrange interpolation polynomial of degree 3. Okay, yes, we need 4 points. If you look at this question, what is the difference between this question with the previous questions?
4 data point.
Yes, 4 data points. Just now there are only 3. And yes, for the previous question, you are asked to estimate for an intermediate value for the x. Estimate. Right? Estimate. You see all the example just now, estimate. You are asked to estimate the intermediate value, okay, from the independent variable. But for this example, you are not to ask to estimate anything. Fx function. Okay, so now we look at the solution. So 4 data points, that means 0, 1, 2, 3. Okay, 0, 1, 2, 3. Then you need to form your L0, L1, L2, L3. Then substitute all the X0, X1, X2, X3. Okay, and also Fx0, Fx1, Fx2, Fx3. Okay, so the one from the denominator we can simplify. This one we can simplify to one value. But here, you see, you have the X. Since you are asked to get the polynomial function, that means you can't stop here. You have to simplify. You have to simplify the function into a polynomial function, the simplest one. Okay, that means you have to expand, and then group those for x cubed, group those for x squared, x, and constant. Okay, so this is the difference between the one that want you to estimate any value for x and the one it doesn't. Okay, it just wants the approximation, the polynomial function. Okay, so the one that you need to do the estimation, we don't have to simplify the function because we just want to use the function to get the estimation. You get what I mean? If you look at this, you see we don't simplify. We don't simplify this. We just substitute the x by negative 3.8 to get the estimation. Because the question is asking to get the estimation. Okay, we don't have to expand. Just substitute the x value. But when you ask to construct for the polynomial function, you have to expand, simplify into this, something like this. Okay, next, this is another exercise. Okay, this exercise, you are given a function, a quite complex one. So this one, we need to get the points from the function. You are okay, after you get that 4 points, then you can start to find for the Lagrange interpolating polynomial of degree 3. Okay, then estimate for x equals to 5. Okay, when you read on the question, you must get some idea on how you need to carry on. Okay, how to carry out the working solution. Do you have some idea now with what you need to do? Yes or no? Get the points first. Get the points first. Substitute the x into this x. Get the corresponding y value. Okay. Get the points and then form the polynomial function. Then substitute all the x0, x1, x2, x3, and all the fx0 until fx3. Then substitute x by 5 to get the estimation. Okay, so now we try this one first. Okay, we try this question first. It's a debate. We want to do the estimation by using the given 3 points. Okay, because we want to use the second order polynomial function. Okay, estimate 1.8. Okay, you have these 3 points. Okay, you have these 3 points. You have these 3 points. And your I values is 0, 1, 2. Okay, 0, 1, 2. So we want the second order. Second order, that means the fx, you have L0, L1, L2. Write it up first. You need the L0 x fx0. L1x fx1. And L2x fx2. Okay, that form the L0. Form the L0, L1, and L2.
Tambah.
We haven't signed your attendance.
Siap. Lakukan. Bantunya dulu sih. Ya, udah benar dari sendiri. Jadi dua kan? Jadi dua. Yang kita lakukan tidak jadi. Kita bagi Jadi punya.
Oh, oh,
Okay.
Aku kapan? Mana lagi tu? Kita jadi kosong kan sebi. Tapi dia over juga. Jadi nombor depan tu yang tu kan, belakang tu yang S0 yang sama dengan dua. Pulau dia pening lah. Mana kat tuan? Nombor depan bukan nombor belakang.
Nombor belakang apa?
Ini kan kamu sendiri.
Yang satu itu L kosong. Sebelah L3. Mana?
Yang sebelah 8, sebelah 8 dia.
8 dan 3.
Kau pula? Kan ada satu koma 11.
Ini X, Y, X, Y, X, Y.
Y je nak masuk mana?
Y itu masukkan dekat S kosong ni. L kosong S.
Kau nak guna ni ya? Kau dah guna ni ya?
Ini Y.
Yang kat sebelah tu kuat. Kau ambil 3
Aku pun
Ya, sebab ini kita bagi 2 ke dia? 4/9 equal 4.2.
ini X, Y. Oh ni.
Why dia guna tu yang kat sini?
Maknanya ini 11.
Ah, enggak gitu.
Apa nak buat dengan rumbis? Pak I tu.
Okay, done?
Not yet. Wait.
Okay. I is 0. Okay, I is 0. So J is 1, 2. 1 and 2. So x minus x1, x minus x2. I is 0. So this is x0, x0, x1, x0 minus x2. Okay, for the second term, when I is 1, J is 0 and 2. 0 and 2. So x is 1. So x1 minus x0. x1 minus x2. This is fx1. It's one more. I is 2. So J is 0 and 1. Okay, J is 0 and 1. This means x minus x0, x minus x1. Okay, 0 and 1. I is 2. So this one will be x2. Minus below this x2 minus x1. fx2. Okay, once you get this, you can start to replace, okay, the x1, x2, x0, all this from here. So this is the first point, okay, x0, x1, x2. Okay, this is your fx0, fx1, and fx2. Okay, substitute all this point into the formula, okay, the equation. X minus x1. X minus x2. X0. -1. -1 minus 1. -1 minus 3. And the first y value is 11. X0. X2. X1. Second one is 8. It's 0 and 1. Second one is 1. Three. 3. So far, okay? Okay. And lastly, we want to find for F 1.8. Okay, F 1.8. F 1.8, that means all x we substitute by 1.8. -2 times -4. 8. Okay, 1.8 plus 1 and minus 3. Um, 2 times -2. Plus 1 minus 1. 4 times 2. So when you use a calculator to solve all this, you should get 6.24. Do you get 6.24? Yes.
Yeah.
Okay, good. Okay, for those who have done this, you can try the last question. Okay, the last question is not. Fine.
Kena buat gila semua. Kita dah kena. Kita substitute kat sini kan. Tapi kalau kira yang dalam ni dia tak substitute kan. Kalau kira substitute. Itu dia punya format. Dia yang atas tak payah. Dah dapat satu tak payah.
So you can dapat terus 0.8 times. This is negative 0. Negative 1 point something, right?
Betul. Otherwise kalau buat macam ni, on kan?
Sama kan? Sebab saya tak bawa calculator. So I just assume you are dapat.
Dapat.
Okay, done. This one done.
Dan
And then we look at the last question. The last question, you are given a function.
bukan bila saya tak boleh. Kita buat satu.
Okay, you are asked to use
Pas lah itu.
1, 3, 4, 7.
Good.
1, 3, 4, 7. So you need to get the values from your calculator. Okay, this is a sine function, trigonometric function, so make sure your calculator is in radian. Okay, now take out your calculator. Substitute x by 1. What do you get?
Jap, wait. Negative 1.2. Ambil berapa desimal?
4 decimal places.
Negative 1.2662.
Yes, negative 1.2662. When x is 3,
Negative 5.6349.
do you all get this? When x is 4,
Negative 20.6631.
negative 377.896 4
Fine.
5.
Bila yang saya tambah. Ya, saya tambah.
Okay, so this one, it wants you to use cube order of 3. Okay, order of 3. Okay, we use 4 points. Okay, 4 points. That means I is 0, 1, 2, 3. Okay, 4 points. 0, 1, 2, 3. Okay, so your F X will be okay, L0, F, L1, F, L2, F, L3, F. Then form the L. Form the L. When I is 0, that means your J will be 1, 2, 3. Okay. When L is 1, when I is 1, J will be 0, 2, 3. Okay, 0, 2, 3. When I is 2, J will be 0, 1, 3. Okay, 0, 1, 3. Okay, I is 2, so X3. The last one, I is 3. That means J is 0, 1, 2. For this question, you are asked to estimate for S5. Okay, F5. Okay, so remember this one is your X0, X1, X2, X3. Your X must be in order, okay, increasing order.
F5. Ya. Banyak juga ini manfaatnya.
X1, X2, X3. X not S1. It's 0, 2, 3. 0, 2, 3. What is the X1 just now?
Actually 5.6349.
0, 1, 3, 0, 1, 3. X
20.6631.
negative 2, 0,
0.6631.
1, 6, 6.
6631.
6, 6, 3, 1. Negative 20. Okay. 0, 1, 2. 0, 1, 2, 1, 3, 4. This is negative 377.8905.
8905.
This one. Get
Aku tunjuk 4. Balik pula. Yeah. Siapa yang tengok video ni tadi betul. Kena ramai yang Apa main tadi tu aku dah fokus ke lah jangan main phone. Kan kena tengok lagi macam mana. Kalau dah cakap betul dasar. Aku
This function, okay, this function is the estimation to the function just now. You have ex,
X2
x square minus x square minus ex plus ln x over square root of x plus sin x. This is the interpolating polynomial function estimation for this function. Okay, that means we use interpolating polynomial to estimate a cubic function for this function. Okay, done. Okay, so we have done the syllabus for week 7. This is for week 7. That means in next class, I will start the week 8 syllabus. Okay, week 8 syllabus will be differentiation. Okay, differentiation. Okay. And now I want to continue to the quiz. Quiz 2.